want to make sure that my answer and the calculator are the same. They should be the same. They should be the same. All right. So if you can find the vertex from your calculator, you are in good. You're in good shape. So now I will cancel negative 10 here. Then I have negative 10 this side. Let me write it here. Okay. I want you to see that the standard form of a quadratic function, first of all, standard form is f of x equal to x squared plus bx plus c. But the vertex form, which we are trying to change this to, is a, the leading coefficient, into x minus h squared plus k. All right, so now we have changed from standard form to the vertex form. And we could be told to find the vertex. We already did find the vertex. For me to find the vertex, I have to look at my h here, h, and look at the k. Look at the original. That equation has a negative there, so h is 2. H is 2. K, look at k. It had a positive there. Therefore, actually, the value of k is negative 10. So the vertex of this parabola is to negative 10. The same thing as what we had in our calculator. So you will be told in test number 2, you'll be told to change an equation from a quadratic equation from vertex form to standard form, or from standard form to vertex form. You'll be told to do that. So we're going to find another one. We have to do it until we do it, and after some time we add in what is called completing the square, because so what we do one more of changing from vertex or standard form to vertex form. Changing from standard form of quadratic function to, okay, now look at number 2. For the quadratic function defined at the right, write the function in the vertex form again. Write it in the vertex form again. Give the vertex. So you will always be asked to, it's if you finish this class, you should know how to do this. Okay, so the first thing I want to do is throw the constant term to the left-hand side. The constant term is negative 1. So I will now say positive 1. That means plus 1 on both sides. 1 plus p of x is equal to whatever remains in the left-hand side. Negative x squared minus 3x. Actually, it's plus there. And if I like, I can take away, I can put negative outside here. So negative outside x squared minus 3x. Okay. All right. So now I am working, because I put this negative here. I'm going to put it here. Divide the linear term, the coefficient of the linear term, by 2. So I have negative 3 here. If I divide it by 2, I don't want to write 1.5. No. So I'm going to carry on with. So I'm going to write negative 3 over 2 squared. Okay. And whatever I do to the right-hand side, I will do it to the left-hand side. I want you to know that I took negative off. So when I am trying to, I'm going to square this, and I'm going to bring it here. And that is 9. Actually, it's actually 9 over 4. So I'm going to write 9 over 4 here. But I want you to remember, because of negative here, I'll put negative 1. plus 1 that is already here plus p of x. And then the next one I want to do is open the parentheses. I have x, take one of this here and take one of that, 3/2, and that is square outside. Simplify what is in the left-hand side. So 9/4 plus 1 is the same as 9/4 plus 4/4. That means I now have 5/4 remaining on the left-hand side, and it's negative. So if I add 5/4 on both sides, I have plus 5/4 here. 5/4, not 5/5. So I have 5/4. At this point, I can actually write it as a decimal, 5/4. Therefore, the function is now looking like a vertex form. The function is looking like a vertex form, so I just have to write the function notation. All right, so the leading coefficient is -1. In other words, the graph I will have will be a maximum. If the leading coefficient is positive, the parabola is a maximum. And what do we mean? Concave down. This is a maximum, concave down. If the leading coefficient is positive, the graph is a minimum, concave up. All right, so when the leading coefficient A is greater than 0, we have minimum. When the leading coefficient is concave down, it's a maximum, x or A, our leading coefficient is less than 0. Okay, so now we have converted it from the regular to the vertex form. We can be told to find the vertex, and the vertex will be 3/2 and 5/4. And then if you like, you can actually put this original equation in the calculator and check your answer. It's always good to, if you're told to show or work, do it analytically. That's fine but if you have a calculator, that helps you a lot. So what I'm going to do is plug this equation in my y1, plug the equation in my y1, and look for, of course, whenever you look at this equation, it has a negative leading coefficients. You already know it's going to be a maximum. The parabola will be concave down, so it's a maximum. Okay, so the graph has to look like this. But what you're looking for is the point at the top, the maximum point. So I'm going to put the number or the equation in y1, negative x squared plus 3x. Because people make mistakes, you want to check that your maximum point corresponds with the maximum that the calculator give you. That the calculator you're going to have from the calculator. So they don't have to ask you to use calculator, but you want to make sure you know that you can use calculator. So I think my windows are good. So I can just sketch it, see if I'm going to have what I need. So I see it's a maximum, and I'm looking for the maximum point. So how do I find the maximum point? I will ask my calculator to give me. How do I ask my calculator? You do second calc. I already know it's a maximum. So I'll select number 4. Now I'm asking my calculator to give me the point at the top, the maximum point. And my calculator is asking me, is this the left bound? Yes. Select that. And I'm going to arrow to the right. And that's the right. Is that the right bound? Yes. Do I guess the maximum point for you? Yes. It's going to be some kind of fractions. All right, so you see that answer is good. You can change your answer to decimal. So it's 1.49, approximately 1.5 and 1.25. The maximum point, in other words, the x and y coordinate at the top there is. So don't forget to check your answer, especially whenever you're told to find the maximum point or minimum point. Another way you could be told to find the maximum is by formula. You can be given the formula for finding the maximum and you're told to calculate it. Calculate the maximum point in any given quadratic function. And so I'm going to give you this formula now. Let's do it. Remember that all this I'm saying, all the things I'm saying are in the PowerPoint, but we don't have time to read the PowerPoint because we actually have another test on Monday, test number 2. And in this test number 2, there are 7 sections that are going to be in this number 2. Question 2. So we are going to do our best, but look at this question. If I'm told to use the formula to find the maximum point, this is what I'm going to do. I'll be given this formula, minus b over 2a f of minus b over 2a. Okay, so this is the formula for finding the maximum point. If you're given the formula, remember that my labs is marking step by step. So sometimes you wonder, why is it that my labs did not give me my full grade? We set it up. My lab maths will set it up to mark your paper in steps, show your work. Even though it's a computer, but it detects that you did some steps. Okay. So what is b? By the way, when I'm given this quadratic function, what is b? Remember when I wrote the quadratic function? A is the coefficient of the quadratic term, which is -1. B is the coefficient of the linear term, and C is the constant term. So if you're told to use the formula to find the maximum point, then you put B here. What is B? B3. So we have 3. Remember, that's a negative here. And A is 1. 2 times -1 is -2. So I have -2 here, negative, is going to positive. So that is positive 1.5. So the x coordinate of the maximum point is what I have, 1.5. And then what this is saying is substitute your x coordinate in the original function. Substitute this x coordinate in the original function. And so what you're going to do is negative, which is original function. Wherever I see x, I put 1.5 squared plus 3 times 1.5 minus 1. When you simplify this, your answer is going to be 1.25. Or you can actually put it in your calculator because this function is already in y1. So it's in y1. I'm going to clear this. Okay, so I want to ask my calculator to give me, check it out. We still have the function in y1. All right, so I'm going to second quote. All right, and I'm going to tell my calculator to give me the value of b, which is substitute 1.5 in that function. So I'll do vars function y1. In other words, I just told my calculator to bring down that function in y1 and substitute 1.5 for me in that function. So instead of doing it the long way, you have, by writing the formula and plugging in, you have shown you know what you're doing. Don't waste all your time. That's why you don't finish. Somebody told me I did not finish the test. I said that's why it's timed. Okay, see, you get the correct answer, but you need to know how to manage your time. And by the way, when you're taking your test, I set your time to be reading So if you're looking at your clock, you see that it is checking out the time. Don't give one. If you don't know a question, skip it. Go to the one you know. Start from the question you know. Don't start from the one you don't know. Don't impress anybody because you're not even impressing anybody. If there are 20 questions, if you do well in 15, you score 15 over 20. If there are 20 questions and you're solving one question for 30 minutes, no, you don't want to do that. You're wasting your time. Do the ones you don't understand the last. If you don't have time and you can do 19 out of 20, you made an A, and if you did well. All right. Okay, one last one. Let's do number 3. Number 3, find the vertex. So this time they have actually factored it. They have converted it from the they have converted the function to vertex form. All they want me to do is find the vertex. Before you do that, I would like you to write the function f of x. Write vertex form for yourself. A into x plus minus h squared plus k. This is the formula. So you now compare the vertex form you have written with the equation. So if you note now that there is a negative in the original function, there is a negative here. Therefore, h is not negative 9, because that's the mistake that students make. H is 9. So the vertex is 9. K is, this sign here is supposed to be plus, but it's changed to negative. Therefore, K is negative 3. So the vertex is 9, negative 3. It's very easy. So make sure you write the original vertex form and compare it with the equation you have. That way you don't make a mistake. This is an easy question, and you don't want to fail an easy question. Let's quickly do this one and then we get away from here. All right, give the coordinates of the vertex. See, sign change here. So h is negative 1. Sign change here also. K is negative 4. I bet you can do this. So the only way people miss it is they don't know the formula. You don't know the formula. So whenever you're told to, if you're given a converted form, it's already in vertex form. All you need to do is make sure you know the formula. So compare that. See, there was a negative sign here, but it changed to negative. So that's why this is negative. There was a positive sign here, it changed to negative. That's why this is negative. That's it. Okay, we want to go to completing this. Let's go and complete some square. So you can do number 5. We can do a whole lot of this. Use the vertex formula to find the coordinates and vertex. Yeah, but I know you can do this now. Graph the function. You can do this. Or use the vertex formula, you graph the function. Let's see. If I don't see completing the square here, I will go to, all right, I will go to determine the coordinates of the vertex, which means you have to graph the function. All right, so it didn't ask me to do a whole lot here. And that's all. Okay, so let's go to 3.3. This is 3.2 if you came in late. So I'm leaving here. I'm going to 3.3 because the reason why I'm going to 3.3 is that we need to do as much as we can, because next Monday will be our test. Okay, so I'm going to make this bigger. This is 3.3. And this is solving quadratic function. There is a formula called square root method. So you notice that this is easy to solve. Use the square root method to solve this problem. So you have x is equal to plus or minus square root of 121. Square root of 121 is 11 plus or minus 11. So that's not a big deal. So let's go to number 2. We got to be careful with number 2. Before some of you came in, we talked about complex numbers. Complex numbers. So you just have to be careful. So you have to square both sides, find the square root of both sides. All right, so I have x squared is equal to plus or minus square root of negative 20. Square root of negative 20 is a complex number like we just said. So you want to write it. And remember that you have to, whenever you take square root, you cancel this. So x is equal to plus or minus. I want to factor 20. I can say 4 times 5 multiplied by square root of negative 1. We already know that square root of negative 1 is a complex number. We already know that. We just said that this morning, actually this afternoon. So all we need now for is a perfect square. So x is equal to plus or minus 2 root 5 I. This is I. And that's my answer. Okay. Well, so many complex number. Every complex number has a conjugate. So the first plus 2 root 5I is the first one. The conjugate is negative 2 root 5. Okay. Let's go to the next one. All right. So which equation is set up for direct use for a zero factor rule? Which one? I can use zero factor in this one. We can use zero factor for B. Zero factor B. Actually, if you can actually do this one too. If two functions or binomials are multiplying each other, then you can use zero property. So I can do 5x minus 2 equal to 0, or x minus to 0, and then you solve, you get x equal to 2 over 5 here, and x here, x is equal to 9. So this is zero property. There are things you can do. I don't want to be doing the things you can do already. Let me go to, if not, I'll go to the practice test, because there are some practice questions that we need to know how to do. Those practice questions are already set. So I'm going to take 20 questions from those practice questions. Okay, so but this one says solve by quadratic formula. I know that you must have heard about quadratic formula before. So let's solve by quadratic formula. Solving by quadratic formula, whenever you have x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Well, let me stop here and ask, can you hear me? Do you have any question, any problem at the point we are now? Any question?
No, no questions right now, but I'm not finding
Okay,
the paper that
so
you're working on.
we are trying to solve this number 16 by quadratic formula. Okay, and the first thing I want to do is it in standard form? Does it look like, yes, it is. Is collected. The leading the first term is degree 2. Second term is degree 1. Third term is degree 0. Okay, so we can do it like that way. At this point, the next thing I will ask myself is, have I collected A, B, C? My A is 1, my B is 6, and my C is negative 4. Okay, before I continue, there is something called discriminant. Let's talk about it now, because if you know how to evaluate discriminant, your whole world will be easier. Okay, so uh, D is called discriminant, and it is b squared minus 4ac. If D is equal to 0, you have one real solution. One real solution. So which means the quadratic function has one real solution. If d is greater than 0, you have two real solutions. Two real solutions. In other words, the parabola cuts x-axis in two places. Here, the parabola cuts x-axis in one place. All right. If d, there are three cases. If d is less than 0, if d is less than 0, then you have imaginary solutions. In other words, remember that the d is discriminant and it is the quantity inside the radical sign, the radicand. D is the radicand. Anytime you simplify d and it is negative, less than 0, then your solutions are imaginary. And you have to find the imaginary solutions. You don't say no, no solution. No, you do not say no solution. You find the imaginary solutions. So that to just make a whole word simpler, let's find the value of d in this number 16. Because if I know how to find d, I know how to solve almost all quadratic equations. Okay, so I have already found my A, B, C. So B is in this particular question 6. Okay, so B is 6, 6 squared. Notice that B is B squared minus 4AC, right? Minus 4 times A is 1 and C is negative 4. Okay, B squared minus 4 times A times C. These two negative signs have changed the sign, and it is 6 squared is 36. 4 times 4 is 16. So the radicand is giving me a positive sign. In other words, my answer is actually 52, something like that, 52. Therefore, the discriminant is 52 greater than 0. So I have two real solutions. If you don't agree, let me know. People make mistakes. So right now, I can now rewrite my answer minus b minus 6 plus or minus square root of 52 all over 2 times 1. All right. So now you can simplify your answer. It's not imaginary. That's all. You find the answers. You can simplify it in a way that it is easier to solve. Let me see. I have 20. If I divide by 2 there, I have 26. So 4 times 13. So actually, we can see that it could be negative 6 plus or minus. Let's divide this by 4. I see if I can divide. So that's 1. That is 2. 4 go here. That is 3. So it's going to be 4 times 13. 4 times 13. I have to make sure that what I'm saying is right. But if it is not, correct me. All right. So now I can now bring out something from the radical sign. So I have negative 6 plus or minus 2 root 13 all over 2. And I still have to simplify more. And let me do it here. So I have negative 3 plus or minus root 13 because I'm simplifying by 2. Okay, you can be told to leave your answer in exact form. If the question says leave your answer in that's exactly what I'm saying here. Type an exact answer using radicals. It means you have to leave your answer in radicals. If you type a decimal, computer that grades your work in my lab maths doesn't know who you are. When it says leave your answer in exact form, please leave your answer in exact form. In other words, your answer will contain radicals. when we do logarithms, if it says leave your answer in natural log, leave your answer in natural log. If you simplify, it gives you a 0. I hope you understand. Any question about the exact form? Okay. So we solved one equation by quadratic formula. Maybe let's do another one that way. So this is another one. Solve the following equation for any equation with a real solution. Support here. So this time they did not actually tell me to use quadratic formula. Okay, let's do this one. They say use the quadratic formula. Okay, so we know we have done 2 quadratic formula, and then we shall do completing the square also. All right, so we are told to use quadratic formula here. So the first one I want to do, I'm going to do it up here. I have 2x squared minus 9x, and I want to bring -1 to the left-hand side equal to 0. So it can be in standard form. So I made the quadratic function look like a standard form. The next thing is to find the coefficients. The leading coefficient is 2. The coefficient of the linear term is -9, and that is B, not A. So the coefficient of the linear term is -9. The constant term is -1. Then what I do is check the discriminant first. So I'm going to check the discriminant. That tells me the whole story, because I don't want to be solving a problem and later on find out, oh, it's a complex solution. If it's complex solution, I want to know it now. Okay, so the discriminant, D, is B squared minus 4AC. So -9 squared minus 4 times A is 2, C is -1. 9 squared is 81. 81 minus, this is going to be plus, minus. It's plus. 81 minus 8 is going to give me 73. Okay, so the discriminant is 73, 2 real solutions. Therefore, now I say plug into the quadratic formula. I can just do that without putting everything in. So I have -9. B is -9, so no, minus 9 plus or minus square root of 73. Instead of putting in everything, I already know the value of the discriminant. Therefore, the radicand, if I know the value of the discriminant, then I know the radicand, which is 73. Therefore, now I have divided by 2, and then simplify. Remember, most of the time you're told to leave your answer in exact form. See it, leave your answer in exact form. In other words, do not go and use your calculator to find square root of 73. You're messing yourself up. Leave your answer in exact form. Minus minus is plus, so your answer is 9 plus or minus square root of 73. Full stop. Divided by 2. Don't continue with the simplification. Any questions so far? Unmute yourself. Ask your question. Any question? Now we're going to completing the square. We have already done converting the standard form to the vertex form. It is exactly the same method. So, except that I'll be finding the solutions this time. Okay, because I'm going to be finding the solutions, I wouldn't put any f of x. So, this is the quadratic equation that I'm given. I'm told to solve using completing the square. This is the way I solve it. There might be other ways, but this is what I do. So I will throw the constant term to the right hand side. So I have x squared minus 18x. Then throw the constant term to the right, which is 4. And I will keep a space. See this space here. Then I will find the linear term and find the coefficient of the linear term. It's negative 18. Divide that coefficient by 2. Coefficient of the linear term is negative 18 divided by 2, negative 9. So I add plus negative 9 squared. I put that on both sides. Whatever you do to the left, do it to the right on both sides. Now I open a parenthesis on the left-hand side. Pick 1, x, pick 1 here. Remember there is a negative there, squared. On the right-hand side, I will simplify. Negative 9 squared is 81. 81 plus 4 is what I have here. If I add them together, I have 85. So 85. Therefore, x minus 9 squared is equal to 85. Any question? You can disagree though. If I write something it doesn't make sense to you, let me know. Okay? Now at this point, I am solving for x. That's the difference between changing it from standard form to the vertex form. I am just solving for x, so I'm going to find the square root of both sides. Find the square root of both sides. Square will cancel with square root. Find the square root of both sides. Remember that whenever you find the square root, you got to write plus or minus. All right, now that I have squared both sides, found the square root of both sides, on the left-hand side I have x minus 9 remaining, but I'm solving for x only. So I'm going to write x is equal to 9 plus or minus square root of 85. Well, guess what? You are told to leave your answer in exact form. Do not go to simplify that. It makes your world easier, by the way. So that's my answer. And by the way, I will check and see if that the quantity in the radical sign, which is the radicand, is the radicand. Can I simplify it? If you can simplify it, that's fine, but I don't think so. So you leave it like that. Let's do another completing the square. Any question? That was the first completing the square. Remember we have talked about today. We talked about complex numbers. I know you're going to read it up. We talked about converting standard quadratic function to vertex form. We talked about solving with quadratic formula and the discriminant. We're talking about completing the square. You can do this because in this section there are 7 of them, which you have a test on Monday. We are going to meet only one more time after today. So I hope you know what you signed into. This is a fast track class, a 5 weeks class. It used to be 3 months, but they divided it into 2. That's why it's a 5 weeks class. So I'm not too fast. I'm trying to do what I can do. So just whatever you have to do, do it so you make an A. Unit 1 test was very good. There was a lot of A's, but a couple of people didn't finish. They told me though, I can't help it. I gave you 2 attempts. I gave you 90 minutes, and that's how it's going to be all the time. Anyway, let's continue. We're going to do 2 more completing the squares. All right. 2 more completing the square. Using completing the square to solve a quadratic equation. All right. So on this one, let's talk about an equation that has a coefficient. If a quadratic equation has a coefficient, I mean leading coefficient. The leading coefficient is not 1. That I'm talking about. I'm talking about you are trying to complete the square, but the leading coefficient is not 1. It's going to be a little bit long. So let's go to number 29 and try that. So the first thing you want to do is to divide all through by the leading coefficient. And that's what I'm going to do here now. Divide all through by leading coefficient. I have x squared minus 7 over 2x minus 17 over 2x divided by 2, sorry, is equal to 0. Next thing I'm going to do is throw the constant to the right hand side. So I have x squared minus 7 over 2x is equal to, it is minus on the left hand side. It's minus on the left hand side. The next, the right hand side will be positive, plus 17 over 2. And then I'm going to add something here. So let me make sure that I put this parenthesis. And what am I going to add? Because anybody, let me just give you a quick 1 second. What am I going to add in the parentheses? Somebody, let me see. You omit yourself and tell me, what am I supposed to add there? Okay, let me see if I still have somebody in this class. All right, we're only few, but you want to answer the question or do I continue? Anybody? Okay, I am going to continue. So what I'm going to do is find the coefficient of the linear term, which is negative 7 over 2 divided by 2. If I divide negative 7 over 2 by 2, I have negative 7 over 4. I hope you agree. So that is negative 7 over 4 on both sides, square it. And I do the same here. I can actually put it in front. So I have negative 7 over 4 here also. So negative 7 over 4, and I can square it immediately. So I have 14, 7 times 7 is 49, 49 over 8 for the right hand side. 4 times 4 is 16, forgive me for that. 7 times 7 is 49, and this is 16 plus. Okay. And then I will open a parenthesis on the left hand side, take 1 from here, and take 1 from, I'm taking 1 of each pair of the squares. And then find the lowest common denominator on the right. The lowest common denominator is 16. So I have 16 here, 49. 2 go into 16, 8. And here I have 8 times 17. Okay, so this is what I have in the right hand side. And then I will find the square root of both sides. Find the square root of both sides and then finish. Okay, if I can do that quickly and simplify later, I will have x minus 7 over 4 square root, and square goes out, is equal to plus or minus square root of the quantity on the right hand side, 49 plus 8 times 17 all over 16. Then add 7 over 4 on both sides. So I have x is equal to 7 over 4 plus or minus. If you look at this, denominator is 16. 4 can come out. 4 will come out from here. That simplifies our problems. Okay, so I can now say my answer is 7 over 4 plus or minus 1 over 4 here, square root of, at the right hand side. Then you get a calculator. So get your calculator. And so I have 17 times 8 17 multiplied by 8, I have 36 plus 49. I have 185. Then I find the square root of 185. All right, so before you find that square root, ask yourself, am I told to leave my answer in exact form? Yes. So if I'm told to leave my answer in exact form, then I don't need to find, I can just leave the square root of 185. That's it. So you simplify your answer in such a way that there's a radical there. So I'm told to leave my answer in exact form. That helps a whole lot. All right. So number 33 says evaluate the discriminant. So this time the question is about discriminant. And if we know what the discriminant is, then they're asking us if the discriminant is equal to 0, what does it mean in the equation? If it is greater than 0, what does it mean? If it is less than 0, what does it mean? So, first of all, we need to know to evaluate the discriminant. Before I evaluate the discriminant, I have to find the coefficients. The leading coefficient is 4. Coefficient of the linear term is -20. And the constant term is 25. So let's evaluate the discriminant. The discriminant is b squared minus 4ac. B squared is 20. So -20 times 20, -20 is going to be 400. 20 times 20 is 400. And it doesn't matter because negative squared is positive. Minus 4 times A is 4, C is 25. Okay, so we're told to evaluate the discriminant. We want to check this other side. 4 times 4 is 16, 16 times 25. So let's find out what it is. And we decide what happens to the discriminant. So what is 16 multiplied by 25? Is 400. Therefore, the discriminant is 0. 400 minus 400, it is 0. So it's time for decision. The discriminant is 0. Choose the correct answer. One solution, one rational solution. One solution. That's it. Okay. Number 34, another one that says find the discriminant. And by the way, this is homework 3.3. So we're almost doing all the homework here. Let's do number 35, discriminant again. So this one, find the discriminant. So in this particular one, we have b squared. So -4 squared minus 4ac and 4 times c. -4 squared is 16. 16 minus 16 is 0 again. Wow, one real solution or one rational solution. All right, so the discriminant in number 35 is, I don't want you to think that it's going to be 0 all the time. So let's find the one that's not 0. Okay, well, let's do number 34 because I'm sure this one is not going to be 0. All right, so the discriminant here is b squared, so 9 squared minus 4 times a is 8 times c, this is 4. 9 squared is 81 minus, so let's get a calculator, 16 times 8. 16 times 8. And we have 128. So 16 minus 128, you already know that the value inside the radical sign is negative. Therefore, you have two imaginary solutions. Two imaginary solutions. I hope you agree. If you subtract 128 from 81, you have negative. So you have two imaginary solutions. The two of them, one is the real part, the other one is the conjugate. For every solution that is imaginary, that is the real part, that is the conjugate. And by the way, remember to write the answer, the imaginary solution, in standard form, where the real part is without I, the imaginary part has I. All right, I think we can only get to this point today. Let me see what we can do within this time. So this is 3.3 homework, which you should be doing today. So we started 3.1, 3.2, 3.3. I hope you will do the homework for today. Let's go to 3.4 and see what is in there. We may not even get to do it, but we just see what is in there. And then next class we do 4.2, 4.1, 4.2. We still have 5 sections to go, by the way. Next class we do 5 sections. So anyway, let's get to 3.4. And then I'm going to make it big. Find the maximum value. I already showed you how to find the maximum value. Let me tell you, if you don't have time to use the formula, put the function in your calculator. Number 1 of 4.3, put it in your calculator. Draw the graph. Ask your calculator the maximum point. All right, so that's what I'm going to do now. Number 1 of homework section 4.3.4. So I'm going to put in negative 3x squared. Okay, and then plus x minus 1. I'm told to find the maximum point. They did not tell me to use any method. So that's important, which means I can use any method I like. So I'm going to graph the function. And I already know it is a maximum. I will ask my calculator to give me the maximum point. Second calc. And number 4 is maximum. And the blinker is at the top. I'll send it to the left. And I want to answer the question, is this a left bound? Yes, it's a left bound. Then I'll send it the blinker to the right. You make sure that you direct the blinker. All right, then is that the right bound? Yes. It's asking me, do I guess the maximum point? Sure, go ahead. So the maximum point is 0.166, or can just 0.17. And if you're told to leave this answer in exact form, what you do is put this number and change to fraction. For example, this is what I'm going to do now. If I want to change the x coordinate to fraction, this is what I'm going to do. I'm just going to go to main screen, and I'll type 0.16666 and so on. And then I go to math, and I'll change to fraction, and I'll hit it at that. I'll try and change it to fraction. It didn't change though, but it should be able to change it to fraction if you're told to do that. Okay, find the minimum point. The same method, find the minimum point. Solve the equation with quadratic formula. So notice that the quadratic formula is going ahead. Now we shall start using application of quadratic formula. But meanwhile, we have 13 minutes going. So what we're going to do now, I want to go to practice test that should be rationalized the complex number. Whenever a complex number is in the denominator, whether you are told to rationalize or not, you should rationalize the denominator. Complex number should not be in the denominator. All right, so let's get a practice question. That way, I want to make sure you know that before. And so you need 2 practice tests is what I'm going to get now. We are looking for a rational function that has complex number in the denominator. So practice test 2, I have it here. All right, and by next class we shall be talking about increasing and decreasing functions, talking about the functions here. So let me see if I have, so I'm talking about complex numbers again, even though I haven't finished talking about it, because there are things you will see that you really want to make sure you know how to do. If I don't have a question here, I'll put 1, because there's one that like that in your test. I'm not seeing 1, but I just want to make sure you know there's a complex number in. Anyway, I'm going to make up 1 now. Oh, this is it. Number 40. Everybody look at number 40. Question number 40. How are you going to tackle this question on Monday in a test? When you're given this question in a test on Monday, how would you solve it? It is complex number in the numerator, complex number in the denominator. You are to write the quotient in the form of the standard form of a complex number. All right, I want you to make sure you know that whenever a complex number is in the denominator, you rationalize the denominator. So I'm going to rewrite the whole function, 9 plus 7i all over 1 plus I. Every complex number has a conjugate. So multiply by the conjugate in the denominator. And what is it? The original one is 1 plus I. The conjugate is 1 minus I. The same thing in the numerator. Multiply the same thing, the conjugate in the numerator. Then simplify. If you remember, when you multiply with the conjugate, you have actually expanded difference of 2 squares. So I can actually rewrite it as 1 minus I squared, because it's difference of 2 squares. A while ago, we said that I squared is the same as -1. Whenever I is square I is same as -1. So this is where we have I, and so I now have 1 minus minus. I'm talking about denominator. 1 minus minus 1 is 2. So denominator is 2, because the important thing is that the denominator does not contain a complex number. The denominator must not contain a complex number. That is why you are told to simplify. They didn't even tell you to rationalize the denominator, because they're trying to see if you remember it or you know it. And then in the numerator, I'm going to use FOIL. FOIL. First, outside, inside, last. Okay, so now I want to simplify the numerator. I already got the denominator. So let's simplify the numerator. All right, so I have 9 multiply 1 is 9. 9 multiply negative I is negative 9i. 7i multiply 1 is 7i. That's plus. 7i multiply negative I is negative 7i squared. Negative 7i squared. One thing we do know is that whenever we see I squared, it is -1. When we see I to the 4th is 1, we already know that. I to the 4th is 1, I squared is -1. So that's how we're going to use here. So this point here becomes negative. negative, negative is positive. So I'm going to change this to positive. I can take this away. 9 plus 7 is 16. So I have 16 minus 7i plus negative 9i is negative 2i. Negative 2i divided by 2. Okay, so simplifying, I have 8 minus I. My function is now in the standard form of a complex number, where the real part is 8, the imaginary part is negative 1. Any question? Any question? All right, that's about anytime you're told to find the minimum or maximum value, you can use your calculator. If you don't want to use your calculator, use the formula. And what is the formula? What is the formula? The formula, please. What is the formula? The formula is negative b over 2a, comma, f into negative b over 2a. So that's the formula. All right. So if you're told to use the formula, then go ahead and use the formula. The one thing I'm going to do now, the last minute, is synthetic division. Use synthetic division to do number 43. Synthetic division. The worksheet we're doing now is homework for section 3.4. So we are in our fourth section today. We are in our fourth section today. Homework section 3.4. All right, so I am told to use synthetic division. And if I'm doing synthetic division, I have to first of all write the quadratic function, make sure it's in standard form, and I'll put the division sign. So I have seen that the quadratic function, this is a cubic polynomial though, so the leading coefficient is 1, coefficient of the other term is 5, 9, 6. It is in standard form. I have collected the coefficients. The divisor is x plus 2, but I'm doing synthetic division, so I'm going to solve x plus 2 equal to 0. So x is equal to negative 2 is the only divisor I have. Now I am going to divide. Before I start dividing, and by the way, this is synthetic division. Synthetic division. So the first thing I want to do is bring down 1, multiply negative 2 to 1, and I have negative 2. Plug that negative 2 here. Add 5 plus negative 2, I have 3. Negative 2 multiply 3 is negative 6. Add that negative 6 here. Add up. 9 plus negative 6 is 3. Negative 2 multiply 3 is negative 6. Add that negative 6 here. If you add it up, you see that 0. So the remainder here is 0. Therefore, negative 2 is a factor actually. Negative 2 is one of the solutions. X plus 2 is a factor. Therefore, I can now write the quotient. The quotient is, because I divided cubic by linear, the quotient has to be x squared plus 3x plus 3 plus the remainder. There is no remainder. 0 over the divisor. There is no remainder. So I have finished dividing, and my answer is, this is the quotient. Any question? This is another solve by completing the square. And you will keep seeing solve by completing the square. You will keep seeing it. Do we have time? We only have 3 minutes remaining. Okay, so we did justice actually to 3.4. So the next time we come in here, we go to 3.5. So when we come on here, we shall be talking about the polynomials like this, application with Pythagorean theorem, application with polynomials, complex numbers.